All right, so we're completing the square like we did last week. If you were not here last week, the videos are online on Canvas. Complete the square number 3 probably would be a good one. It's just called CTS. CTS number 3. All right, so write 2 down 5. Draw your dotted lines. You might know what I just drew. What is that? Yeah, axis symmetry. Make sure you label it. It needs to be labeled as an equation. X equals 2. Down 5 is right here. There is your vertex. Draw your points. Oops. Draw your parabola. All right. So then they go down here and they say, what form was the previous problem? That was in standard form. What if we gave it to you in vertex form? Can you graph it now? Because, well, obviously they wanted you to complete the square. So that's what we were working on. So then it comes down here and it sets it up for you. So we can ignore this because we've already done it. But what we do need to look at the vertex. So we're looking at the vertex, which is 2, -5. We need the axis symmetry, which is x equals 2. What else is down there? Y-intercept. We already graphed that. 0, -1. What was the corresponding point to the y-intercept? Doubled axis symmetry. 1. All right, here's one that's new to you. I'll put it in purple. Max/min. Peyton, what would you think if you're looking at that? Max or min? Do what? Max is the highest number and min is your smallest number. So which one is important? The minimum is important. Maximum is infinity, right? In infinity, we just don't deal well with infinity. We really want to know what our minimum is. So we have a minimum. And the way to write your minimum, all right, is write your y value, whatever your lowest y value is, which is -5. And then you're going to write the little a with a circle around it. X equals 2. That's the at symbol. So -5 at x equals 2. So on your axis symmetry is also. Okay? You can say -5 on x equals 2 works as well if you don't want to write the little a symbol. All right? We didn't have domain and range, right? All right. So why could we not find these right here? Why could we not find the x-intercepts? It didn't factor, okay, right? It didn't have some clean factors. So we are going to be able to solve that here in a little bit. So I'm going to go over the solving part on this just so you can see it. You don't have to write this down, all right? Those are, what points did we call those things again? Where the red dots are right there? X-intercepts. How do you find x-intercepts? All right, so I mean, this would be 0 equals x minus 2 quantity squared minus 5. Again, you don't have to write this down. You just follow along. All right, so we set equal to 0. Anybody have a plan on how to solve that? You could expand that out. That is one thing you could do. And then you could use a quadratic formula from there, which is a mess. So I'm going to use what we call the square root method. So pay attention. All I'm going to do here would be add 5 to get this perfect square by itself. So that means I have x minus 2 squared on one side and positive 5 on the other. Does that make sense there, Colton? Now, to get rid of a perfect square, you would take the square root. So therefore, this would turn into be x minus 2. And this would be the square root of 5. You see that, Murray? But the other day, when I took x squared and I took the square root of it, I have to always make that what? I have to ensure this is always what? Positive, so I need a absolute value symbol. So therefore, I would have an absolute value over here. And therefore, I would have to do this over here and write down x minus 2 and then negative x minus 2. And then I have to say x is greater than or equal to 2 and x is less than 2. Because I have a piecewise I have to write. So everything we learned back, at the very beginning of the first unit, we have to pull it back in, okay? So we're going to do the absolute value on this one, which means I have to solve this by x minus 2 is equal to the square root of 5. And then negative x minus 2 is equal to the square root of 5. So how do I solve this one? Well, I get x is equal to 2 plus the square root of 5. That is your answer. This one, I'm going to move the negative over. And then I'm going to get x is equal to 2 minus the square root of 5. And these actually end up being conjugate pairs. Those would be your solutions. The intercept would be at this one right here would be 2 plus the square root of 5 comma 0. Anybody know what the square root of 5 roughly is? What's 4? The square root of 4 is 2. So this is a little bit more than 4. This is like 4.2 or 4.1. Look where that dot is. It's right where it should be. And if I did the other one, which is the minus sign, which would be 2 minus the square root of 5 comma 0, this is roughly minus 2.1. So that would give me 0.1 as my answer when I add them together. So as you can tell, that's where my locations would be. So we will learn how to do this. This right here, solving by the square root method, by completing the square first, should become very, very comfortable. Okay? That's where we want you to be with that. So you must be able to complete the square easily first. If you can't complete the square, then that makes this really, really difficult. So today, what do you think we're practicing? Completing the square. What do you think we'll be doing all week? Completing the square. You will get bored of completing the square. Okay? There are some that are challenging problems, and some of you guys might go, if you think of it as a puzzle to unlock and you got to be able to do this, then it might make it a little bit more non-boring. If you sit there and go, oh my God, I think half of it, I got to square it. If you sit there and you mope over the whole thing the whole time, guess what? It will be horrible. Like if I say, oh, I've got to do the trunk or treat. Oh God, I end up candy to kids. The whole time you're going to be miserable. You sit there and you look at all the costumes and the kids just smiling and having a great time. It was a wonderful time. Okay? I enjoyed myself. I went over there scare Cheyenne as much as I can. All right? She was painting faces. She painted more teenagers than kids, which is kind of weird, but that's right. But she had a lot of fun. I think everybody here, it was just a really cool community service. If you don't get to do it, you didn't do it this year, make sure you get involved next year. It is a lot of fun. Okay? Murray was over there. She was just like, I don't know, stitched up. She had stitches all over her face. It's fun. You use your bathroom? We're ready. How many solutions were there? 2. Could we find them quickly? No. All right. So there were 2 solutions And no, we could not find them quickly. All right? We'll get better at that. We're going to go through those processes and get you better. All right, now, moving along. Looking at number 2. It says here, factor the following. Your skills should be really, really good at this. Ellie, what do you notice about all those numbers? Yeah, we could yank a 2 out, making it x squared plus 10x plus 21. I'll give you a second to catch up before I muster my way through this. Now factor it. Go ahead and factor it, guys. Set your 2 parentheses up. What are your signs going to be? Yep, plus and plus. Then what? All right, x plus 7, x plus 3. Now it says solve the following. So how do you solve the following? Yeah, 0 product property, which means that you're going to set these equal to 0. Now, do not be lazy. If you give me down here x is equal to -7 and x is equal to -3, you will not get all your points. You need to show your 0 product property process. The proof in this is writing down each factor equals 2. Then subtracting the -7, so x is equal to -7. Subtract the 3, x equals -3. So -7, 0, -3, 0. -7 is right here, -3 is right here. Anybody know a y-intercept? (0.42). Now, I'm going to show you, you know the openers that we've been doing? Right? Yes, today was polynomials. So, for instance, right here, as x approaches positive infinity, as it's going to the right, what will y do as it goes towards infinity? Well, if I put positive infinity here, positive infinity here, it's positive times a positive, which means it's a positive, right? You're going to go up. If you're going, x is going towards negative infinity, which direction would the y end up going? Well, that would make this a negative infinity times a negative infinity, which would make that a positive infinity. So it would also go up. Guys, in this case here, my end behavior ends up, up. That's what a parabola does. It goes up and up. So that's the same thing. The reason why is that I'm just squaring something. So a negative times a negative gives me a positive. If I put a positive in this, positive times a positive gives me a positive. All right, so there's your end behavior. All right, we got to get a little more specific than that. All right, we're going to go a little bit more specific. What else do we have when we're graphing a parabola? We need a what? We need a vertex. We need to label the max and min. We need the axis of symmetry. So it's a little bit more than our polynomials. Our opener just dealt with x-intercepts, our y-intercept, and our end behavior, and that was it. But when we get to parabolas, we can actually calculate the maxes and the mins. When we're dealing with the cubics and the quartics and the quintics, we can't find those max and mins easily yet. When you get to calculus, there's a very, very easy way to find them, and you'll learn that when you get to calculus. At this point in time, we're not going there. We're going to stop at, hey, find the intercepts in the y, and then as you go further along, they'll teach you everything else. Okay? So we're just going with the basics of the polynomial, but with the quadratics, we're going very specific. Because you started quadratics back in Algebra 1. Remember that? Now it's time to enhance it a little bit more. We got a vertex, axis symmetry. We have a y-intercept. All right? Max and min. Where's your axis symmetry in this one? X equals -5. What falls on this axis symmetry? What point is on your axis symmetry? Okay, you almost said it. What was it? The what? What is on your axis symmetry? What point is always on the axis symmetry in a quadratic? What's the only point that's on there? The vertex. So my vertex automatically has a -5 for your x. All I got to do is find the y. How do you find the y? Plug it in. So that means it'd be like 2 times -5 plus 7 times -5 plus 3. Right, Kate? Make sense? So I'm finding f of -5 is what I'm doing. What is -5 plus 7? All right, what's -5 plus 3? What am I missing, Peyton? Am I missing something? Huh? I have -5 plus 7 is 2. -5 plus 3 is -2. I'm plugging it into my function here. What am I missing? The stretch on the outside. I need to make sure I have my stretch. So let's multiply those three numbers together. What is 2 times 2 times 2? And there's one of them is negative. So that makes that a -8. So this ends up being -8. So I can put -8 right here. There's my vertex. What is your, is it a max or a min there, Aubrey? Tell me. Max or min, Aubrey? It's a minimum. Correct. It's a minimum. And what's your minimum? We write it as what? -8 at x equals -5. See that, Peyton? Really, really easy. You're just going to say if you need a corresponding point, what is the reflection point to your y-intercept in this one? Madison, do you know this one? The corresponding point to the y-intercept? If you know your axis symmetry is -5, over here, somewhere way up here is 0.42. There would be a corresponding point on the other side. And it would be the same distance away from the axis of symmetry because it's 5 to get to here, right? Which means it'd be 5 to get to here. So it's always double what that one is. So it gives you -10. Okay? So double the axis of symmetry to find your reflection of that. Now I can go ahead and connect these dots. I knew that there's a vertical stretch on this, so I'm just going to go ahead and make those dots happen. Now it turned out to be really nice and neat here. We ended up with 2 great points. Now, I know down here, since this is a quadratic, it has 2 solutions. Were you able to find the solutions quickly? And the answer was yes. Now it says complete the square, so ignore what's written here, okay? we're going to start from scratch instead of doing this. We'll just start from scratch. Too bad you don't have any white out, but had I known it was there, I would have gotten rid of it. All right, step 1 of completing the square from CTS. Is add what? Add blanks. Add parentheses. So here I'm going to add my parentheses around this one right here, and this one right here, and this one, and this one. Those parentheses need to be matched. Now, I can't start this one, Peyton. Because if I took this, we're just gonna, don't write this down. You can follow along. I normally do what with this number? I split it in half, right? That's 10 here and 10 here, right? And I put X here and X here, and I put a plus sign here. Now that would give me 20, correct? But does this match that? No. Okay? So it creates havoc. It needs to be like the square root of 2 here and the square root of 2 here in order to make it work. Who wants to deal with that? Cheyenne says, not me. She didn't want to paint faces. No, she wanted to paint faces. She signed up for it. All right, so in this case here, she just didn't want to be scared by me. It was funny, though. That butterfly she was painting on the face ended up being almost like a wasp of some sort. It's like... All right, this right here, to fix this issue, this 2 is in the way, correct? We are going to remove that 2 off of the x squared. If my pen will work. It's out of ink. Oh, there it goes. So I'm going to yank that 2 out. Now, I am yanking it out of what's inside this parentheses. So, Stella, what would make that number then? That makes that a 10. That's right. Now, it's only what's inside this parentheses. The 42 there, Colton, that y-intercept, you leave it alone. Once you set it outside the parentheses, it stays alone by itself the whole time. I have students who mess this up, who don't practice completing the square all the time, and so they screw this up. The y-intercept is untouched. You leave it alone. You only work with the parentheses. Now, Murray, you might be able to figure this one out. Since I removed 2 out of that, we have to do something to that. I got to put a 2 here. The reason why is if this is a triangle, whatever number we put down here, there are 2 triangles we're adding here, Addison. We're adding 2, which means I must subtract 2 triangles here. Does that make sense? So this 2 right here is probably the most important 2, all right? It has to match those. That's why it has to. It just has to match that. All right, now, Peyton. Back to you. We're got our 2 parentheses now. There's an X here and X here. What number will we put in these spots? Yeah, you can see that's 5 and 5. And it'll be a plus and a plus. And it gives us the 10, right? And now the X and the X gives us the X squared. So we've cleaned up our mess of this square root of 2 thing that we had going on earlier, right? So let's fill in the blanks now. To get the back number, it'd be the 5 and a 5 put together, which would be multiplication. 25. Which means there'd be 25 here. So, Ellie, you notice here I'm adding what? I'm adding 50. Which means I'm really doing what over here? If I'm adding 50, I have to do what? Also, subtract 50. I'm adding 0. Whatever I add, I must subtract. I'm not changing the problem. I'm changing it from standard form to vertex form. So the numbers themselves, I mean, overall, are not being changed. Okay, we're just manipulating them to be in the correct form. Okay, so I'm going to have plus 42 minus 50 here. Guys, there is a 2 in front of that. I have an f of x equals, and I finally have f of x equals 2 times x plus 5, quantity squared, minus 8. State your transformations. Yes, particle stretch at 2. Left 5. Down 8. All right, so this one here said complete the square into vertex form. We started in standard form right here. We finished in vertex form right here. If I ask you for transformations, you must be in vertex form, which means I would have to complete the square. So if I'm looking at number 2 right here, if I'm looking at number 2, and I say state the transformations, then what would I have to do with that equation? I will have to complete the square. All right, I just gave you another Now this one here will be a little bit easier to deal with. Why is it easier to deal with there, Peyton? No. Why is this one easier than the one we just did? Look at Yeah, there is no stretch or compression on the x squared. The x squared is already clean, so it's nice and neat. So I'm going to give you a second to go ahead and complete the square. I'm going to come around and help you on these. Go ahead and complete the square on number 2. We'll get to number 3 here in just a minute. We got like 10 minutes, so I'll give you a couple minutes. All your blanks. Start. For those who missed Friday, anybody else missed Friday need a copy of homework? So you gotta make the test work, so. Or come in the morning, you've done before class, and then we'll take pretty smart, so I think good job. I'm gonna try that one too. If you want to go ahead and attempt the number 3, you can't. Because we will, yeah. That's right. Yeah. Yeah, you can complete the square, but this one has a half on it, so yeah, you have to remove it. Fantastic. All right, so I've seen a lot of good work there, Obey. I saw x squared plus 8x plus blank minus 11 minus blank. Set your parentheses up. Good job there. I saw 2 sets of parentheses on most people's paper. I got a minus 11 sitting right here, and then you say what number? I think you guys put 4 down. You said 4 and 4, which gave you 8. No, it didn't give you 16. So you did that right there. Looked beautiful. I liked it. I liked all the y equals you guys had. Looked really, really good. You had x squared, and then you ended up with minus 27. And then you said left 4 and down 27. That was the word for number 2. I'm going to go ahead and put y equals, because it needs y equals all the way down. Okay? All right, looking at the next one. Not as pretty. You find the vertex. There's actually a couple ways you find the vertex. But in this case here, if I'm completing a square, I'm putting 1/2 x squared plus x plus blank minus 1 minus blank. We have to remove the 1/2 has to come off of this x squared. When I do that, when I put the 1/2 here, Ms. Murray, where's the 1/2 also have to go? In front of that one. Okay? So whatever you yank out over there has to be over here. Maybe that's probably the first thing you should write down. If I separate that, I should automatically write it over here, so I don't forget it. Okay? Now, in this case here, that gives me an x squared. There's a minus 1 and a minus 1/2 right there. I got to fill in this. I don't know what that number is going to be. What do you know what that number is going to be? Remember, I'm pulling 1/2. I'm dividing a half off of this. There's a 1 right there. Correct? So how many halves do I have in 1? There's 2. Another way of looking at Addison is when I multiply this back in, if I multiply a half here, I get 1/2. If I multiply a half here, it's got to be 1. So when you said a half, I wanted you to think about when I checked it back in, I added 1/4. That would have made sense. Okay? But I had a lot of students who think the same way that you do. We'll yank a half out, and that turns into a half, and that's not the way it works. Okay? This is the most common mistake made on this particular problem, is when I'm yanking out a fraction, you make this a fraction. Again, it's counting how many halves I have in this number. So if that number is 8, how many halves do I have in 8? That would be a 16 right there. Does that make sense? I need you guys to get really familiar with that. That is the top mistake, and it will be made. Someone will not keep that order. All right, now, half of this number, 1. So I'm going to have an x plus 1 and an x plus 1. Multiply them together gives you 1. So I need to subtract 1. Now I'm really adding a half, so I'm subtracting a half. So it works out beautifully. Okay? And so now I'm going to get x plus 1 quantity squared right here. I'm going to put a 1/2 in front. I'm going to go ahead and write down y equals, so I don't forget that. Actually, I'm going to write it on every single line just for fun, so I don't forget.
How do we determine like after it says plus x plus and like the minuses? How do we determine?
Here,
Then they go up there and
this is always a positive. Here, that sign is from that sign. That's a plus sign, and this one is always positive because there's a PST. It has to be positive. Okay.
And what about the last one?
This one back here? This one's based off your y-intercept, and this one's always a negative to start with. If this was a negative 1/2, then that turns into a positive. Switches it. So I can't always say that that one's always minus. If you're pulling out a reflection, it's going to reflect that piece. All right, so I got negative 1/2 or negative 1 minus 1/2. I've got to make that 2/2, so I get negative 3/2. My vertex ends up being negative 1, negative 3/2, and there is my vertex. Questions? What? Negative 1. What? Here? What? Which one? Here? It's negative 1, 3/2. This is negative 1, comma, negative 3. So, I'm just writing it first. Yeah, we have to practice this.